Okay, we're gonna do some work now in trigonometry. That's kind of where geometry and algebra start to converge. So before we get anywhere, it's gonna make a lot more sense if we just remind you of something in geometry about special triangles. Okay, we have our 30, 60, 90, and we have our 45 degree angle one as well. So let's talk about this just a little bit and remind some stuff that maybe we learned in geometry. So we're gonna have right here our 30, 60, and 90 degree angle triangle. Now you learn from that there's a property that if you go across the 30, that's going to be x. If you go across from the right angle, this is the hypotenuse, that's going to be 2x. Okay, and so we also know that when we look at triangles, the smallest side is across the smallest angle. The largest side is across the longest angle. So 60 is going to be somewhere in the middle. So we know there's x and there's double the x, so we want something that's in between, and we find out from doing a lot of other math, which I'm not going to go into now, this is going to be x times square root of 3. Square root of 4 would be 2, and so square root of 3 is just a little bit less, and that's how that matches up there. Well, that's really lovely, and that's a good thing to know, and that's great if you love working with x's, but what if you sort of forget how that works? Well, let's just draw another one right here. Let's go ahead and do our 30 and our 60. And we're gonna say that right over here, that's just gonna be a 1, okay? Well, what's double 1? Well, double 1 is gonna be a 2. And what is 1 times square root of 3? Well, that's 1 square root of 3, or just the square root of 3, we don't need to write the 1. So there would be an example. If I just want to throw another one out there, sorry I'm doing this on my music board, I just happen to be in my music classroom right now, but that's okay, we can do math on a music whiteboard, why not? Okay, let's just say that this ended up being a 5. Okay, well the hypotenuse is double 5, so that's the 10, and this is just going to be the small side 5 times square root of 3. Okay, so that's just basically how we do that. Now that's great if they give us the 30. However, they don't always do that. So that's the easy way. But now what if they don't do that? What if they make that a little harder? Why don't we just step right over here? We're still gonna remember this one right here as kind of the formula one. But now we're gonna take a triangle. Okay, we're gonna do our 30, 60, 90. But now instead of giving us this side, we're gonna do this. We're gonna give the 1 right there. That's the 1. Well, now think about it. The small side to the medium side, I had to multiply by square root of 3. That's what I did here, right? Small to medium, I multiply by square root of 3. So what do I do to go medium to small? You do the opposite. Instead of timesing by square root of 3, we have to divide by square root of 3. So that would be 1 over square root of 3. And if we did that, what is double? Well, that would be 2 over square root of 3. Now, many of you may know that we shouldn't leave square roots on the bottom. So let's just deal with that. 1 over square root of 3. I'm going to rationalize by multiplying each side by root 3. And 1 times root 3 is going to be root 3. Square root of 3 times square root of 3 is normal everyday 3. Okay? So this is actually going to be 3 root 3. And then, of course, if we double that, that's going to be 2 root 3 over a regular everyday 3. Okay? Could just imagine if I put a 2 there and I just doubled that side. Okay, so again, if I were to really fix this, this would be root 3 over 3. So we have to play with some things a lot. Let's just make up another one. Now that one's big because we're going to do something called a unit circle, so that's why I want you to know that. But just in general, for 30, 60, 90 triangles, let's just say this ended up being a, I don't know, they gave you a 7. Well, that's just going to be 7 over root 3 because I have to divide, and that's going to be 14 over root 3. And then I would just let you go ahead and do the rationalizing to figure that part out, okay? And then, of course, if they did this, if they just gave us that, I'll call that the 1. Well, if that's 1, then this would be 1/2, right? Because this times 2 is that, so this divided by 2 is that, and this would be 1/2 root 3 or root 3 over 2. So that's just how we deal with these. I'm going to show you a lot more later when we get into something called the unit circle of how we practically use this. But here's the big lesson on the 30, 60, 90. Across from the 30 is the unit. Across from the 60 is the unit times root 3. and the hypotenuse is going to be whatever the unit is times 2. There's your 30, 60, 90. Now let me do one more for you. I have to erase the board, so let's just do that real quick. Okay, so now we want to teach you one more, and this one's a little bit easier. This is the isosceles one. This is the 45, 45, 90 triangle, okay? And so on this one, what we learn is that these sides are going to be equal to each other, so those are the x's, and the hypotenuse is going to be x root 2. So if you come up with a situation where, again, 45, 45, 90, where I'm going to have a 1, that's going to be 1, and that's going to be 1 times square root of 2, which is just the normal everyday square root of 2, okay? And again, if it gets weird on you and they give you this one, this is very similar to what we did before. What if they give this as a 1, okay? Well, if they give this as the 1, then down over here, what do? Here we multiply by root 2. So to get here, we have to divide by root 2. And these are going to be the same because it's an isosceles triangle. Now just to rationalize that out, 1 over root 2 times root 2 over root 2 equals root 2 over 2, okay? And there's some problems you can do to experiment with that. But basically, to find the hypotenuse, you just take any one of the legs, times it by root 2. If they give you the hypotenuse, then you just divide by root 2, and that'll give you the legs. Okay? Why is this important to trigonometry? Why is this important to UniCircle? Why is this important to radians and sines and cosines and all that? Well, you're going to learn that in the next lesson, okay? So the next lesson will be the UniCircle, and we'll start showing you how all this will apply. But for right now, get to know all these formulas and how to figure out all your special triangles.